Okay, Algebra 2 friends, this is the Chapter 3 review, and for day 1, we're going to look at 10 through 22 even. I thought that'd be a nice way to get going here. All right, so you're welcome to do more, but I'll make another video for the rest of them. All right, so number 10, I'm looking at it. I have to factor it. The first thing you always look for is a GCF. And you probably have a little party here because these all have a 5 in common. So I'm going to pull out the 5. And I'm going to divide out. So that will be a p squared. It's like backwards distributing. 85 divided by 5 is 17. So this is a minus 17p plus 360 divided by 5 is 72. So that's what I'm looking at. Am I done? I don't know. The second thing I usually look for are specials. And what do I mean by the specials? I mean perfect square trinomial, which we talked about. We're not very good at finding those, are we? Difference of 2 squares. That's definitely not difference of 2 squares. And sum and difference of 2 cubes. And it's definitely not sum and difference of 2 cubes, so it's not a special. After that, we look for the guess and check, which isn't really guessing because we kind of have a nice way of doing things with a list. And then if we're really have a leading coefficient, then you have to look at the old ACer. Okay, so those are the strategies we're kind of going to look at. So I'm going to look at here, p squared minus 17p plus 72, and I'm going to see if it breaks down further. And the way we do that is you make a list for 72. 72, okay, how do we multiply to get 72? It's positive, so they have to have the same sign. 1 and 72, 2 and 36, 3 and 24. I'm using my calculator to help me. 4 and 18. 5 and nothing. 6 definitely will go in there. 6 and 12. That gives me 18. It's looking like we might be done. Oh, wait. No, never mind. What do I have here? 8 and 9, right? 8 and 9, doesn't that equal 17? That equals 17. I need a negative 17, so I'm going to use negative 8 and negative 9. Because it's a positive 72, I have to have the same sign. So I leave my 5 there, which is too bad because I wrote really large. That was bad. That was a bad choice. But I have a minus 8 and now a minus 9. And a lot of you did a really good job, I saw in your quiz, like checking by foiling to make sure it worked out. And that's a good strategy to do there. Okay, so that's it. Number 12, is there GCF? Oh, dogs, there's not. That's sad. You should be sad that there's not a GCF there. Why? Because it's not special either. So we're going to have to guess and check, which is just, too bad. So you're probably going to look at the AC method. Okay, that's what I would do. If you're guessing and checking just the way it is, you can go ahead and do that because 5x squared would only break up 5x and x. You would have to play around with 1 and 14 and 2 and 7 to see if you can get to 17 that way, and you're welcome to do that. Otherwise, we're going to do the AC, which means you change the problem. You take the 5 times the 14, x squared plus 17x plus, well, what is 14 times 5? That's 70, and I'm happy because I see right away what I'm going to use. Hopefully you see it too. It's going to be 10 and 7, but I'll make the whole list in case you didn't. Same signs, 2 and 35, 3 and nothing, 5 and 14, and then 7 and 10. I think that's it. Yay, it's 17. Look, it's 17. Hooray. So we put x plus 7 and x plus 10. But remember, we changed the problem. So what do we do next is we put the 5 back. We have to put the 5 back in both spots, and you look for a GCF. Well, there's not a GCF here, so 5x plus 7 just stays. And these two guys have a 5 in common, which leaves me with an x plus 2. And we throw away that GCF because when we put it back twice. So we need to get rid of one of them. Okay. Number 14, when you look at 14, hopefully after you see there's not a GCF right away, you should be like, oh, this is special. Why is it special? Well, there's only 2 pieces, right? And it's a subtraction sign, so it's difference for sure. And both of these numbers are perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9. So 9 and 1 are both on my list. So that's difference of two squares. Square root of 9n squared is 3n. So then we do 3n in both spots. Then you get 1 plus and 1 minus and 1 and 1. And because they're conjugates, where the different sign there, that makes it cancel and not give you a middle term. Okay, moving right along. More factoring. Okay, I'm looking for a GCF. Do they all have a 3? Oh, they don't. 16. It's just horrible. So if you're not careful, some of you might jump right away to AC, but this guy is actually a special. How do I recognize it as special? Well, this is a perfect square, and this is a perfect square. This one is actually a PST, perfect square trinomial, which means it's going to be the same thing squared. So the square root of 9n squared is 3n. You keep the sign of the second term. Square root of 16 is 4. So it's 3n plus 4 quantity squared. What if you didn't see it and you did AC method? You'll survive. 9 times 16 is 144. You'll get n squared plus 24n plus 144. Hopefully right away you would see that it was n plus 12 and n plus 12. Put the 9 back in both spots, but they have a 3 in common. So it leaves you with a 3n plus 4, and this has a 3n plus 4, and then you would just throw away those GCFs. So you can get it from the AC method if you didn't see it. Okay, 18, what do we got here? Only 2 pieces. There's not a GCF. This is also special. It's not a difference of 2 squares. That 3 really helps you see that. This is a sum of 2 cubes. And the sum of 2 cubes is actually the hardest one to memorize. 2 cubes, you're going to get a 2 parenthesis and then a 3 parenthesis. And then you take the cube root of the first guy. Well, what to the third power is 64? Well, you can make a list if you need to. 2 to the third is 8. 3 to the third is 27. 4 to the third is, ding, 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 64. And 5 to the third is 125. So cube root of 64 is 4x. Keep the sign. Cube root of 125 is 5. So that's what's the first parenthesis. Then to get the last parenthesis, you square the first term. So 4x times 4x is 16x squared. You square the last term, so that's going to be a plus 25. You multiply these two together, which would be 20x, and then you change the sign. So it's a minus 20x. And that is a formula you're going to have to kind of memorize. So you might want to write that down or put a star by it so that you remember to go back over that, because you're not going to remember that when it's time to take that test. That's the one I think you'll forget. Number 20 looks kind of special, but you should hopefully right away notice that there's a GCF on number 20. What do they both have in common? They both have an m in common. Divide it out, backwards distribute. M squared divided by m is m. 2m divided by m is just 2, and that's just it. That's GCF. That's it. And on 22, no GCF. It's not special. 90 is not a perfect square. So we're going to go with the guess and check. Make your list for negative 90, which means one of each sign. And I got to get to a negative 1 is what I'm looking for. So you might see right away what it is, but if not, 1 and negative 90. 2 and negative 45, 3 and negative 30. Does 4 go in there? No, it's a decimal. I should have known that. 5 and negative 18. 6 and negative 15. A little bit extra, but you know. Here, how about 9 and negative 10? Ding, ding, ding. That's negative 1. So it's going to be n plus 9 and n minus 10. Gives me the negative 1 that I need. Okay? So I can make you more practice factoring problems if you need it. You also have the quiz, the practice quiz from before. All these problems are similar to that if you need any extra practice with the factoring, because there will be about 6 or 8 practice factoring questions on the test. Okay, now how do you graph these numbers in the complex plane? If you remember, this is the real and this is the imaginary. So 3 is the real part, 5 is the imaginary part. So you're just going to go over 3 and up 5. And that number is 3 plus 5i. Okay, how did we do absolute value? Well, first of all, you needed to know what absolute value even meant. And hopefully you would remember that absolute value is distance from 0. So you can use either the Pythagorean theorem, which is what I like to do, or you can do the distance formula if you'd rather do that. And we're really going to see how far this number is from 0. Well, -2 minus 7i would be -2 for the real part, -7 for the imaginary part. 1, 2, 3, 4, 5, 6. I'm right off the chart here. There you go. Right down here. And they want to know how long that line is, really. Okay. So we're going to do Pythagorean theorem. They're asking for the hypotenuse of the triangle if I would draw on a right triangle there. You see it? So this length is 2 and this is 7. And they want to know what that distance is. So we're just going to take 2 squared plus 7 squared equals the distance squared. That's 4 plus 49 is the distance squared. 49 plus 4 is 53. So get d all by itself by square rooting. You square root 53, and the square root of 53 equals d. So the absolute value of that is the square root of 53. Okay. Now for the solving. Solving quadratics. This is what the big part of the test is, in my opinion. Okay, here are options for solving. Option 1 is to get x by itself, and you're not going to be able to do that on any of these. When can you get x by itself? If it was something that looked like this, like 2x squared equals 14. Then you could just divide both sides by 2. Square root both sides, you get x squared equals 7. Square root both sides, don't forget your plus or minus, and you get plus or minus the square root of 7. That's the first thing you can do, but you can't do that on any of these. So your second thing you hope to do, that's the next easiest, is to factor. If you can tell it factors, factor. Always easiest. If you can't tell or you don't want to spend time, then you need to go to number 3 or number 4. Number 3 and number 4 are the only two that always work. And that is complete the square and quadratic formula. Now, of those two, completing the square is the easiest to solve, but quadratic formula is the actual probably easiest to do. Because completing the square, like on number 28, I don't want to complete the square for sure, because that b is not even, and then there's a number in front. So if I can't factor it, then I'm going to do quadratic formula. Okay, so those are the methods, and we're going to practice these and see what you want. Now, 28 might factor. It's not hard for me to see if it factors, but some of you would go ahead and do quadratic formula without even thinking, so I'm going to show you both. Does it factor? Well, guess and check wouldn't be bad here, because 2p and -3 can only break down one way. 2p and p, and then 3 and 1. Well, if I put the 3 here, that's going to be 6. That's too big. So the 3 would have to be here, and the 1 would have to be there. I need to get a negative p, so the -3 would go here, and then the +1 would go there. It does factor. If you did AC method, you would change that to p squared minus p minus 6 equals 0. You'd make your list for -6, 1 and -6, or 2 and -3. You would use 2 and -3, p plus 2, p minus 3. You would put the 2 back. Those have a 2 in common. So you would throw out that 2, and then you'd have the 2p minus 3. Okay, so that's how you factor it. If you factor it, and I have 2p minus 3 and p plus 1 equals 0, it's easy. Because if this equals 0, then either this guy equals 0 or this guy equals 0, because that's the only way you can multiply to get 0. So that means that p could equal -1. That's the easy one. This one you might have to do work. 2p minus 3 equals 0. You would add 3. 2p equals 3. Divide by 2. P equals 3 over 2 is the other one. Okay? Now, some of you would not have even tried to factor, though, because the 2's in front. So you would have tried quadratic formula. And you would know that A equals 2. B equals -1, and C equals -3, because we use the ax squared plus bx plus c to come up with those. And then most of you probably sing a song. X equals -b plus or minus square root b squared minus 4ac all over 2a. It's really cute. And then you plug in what we know. Well, what is -b? Well, you just change the sign of b and you get 1. Plus or minus square root. B squared is always positive. -1 squared is 1. Minus 4. A times C is -6 all over 2a, which is 4. So that gives me 1 plus or minus. This becomes 1 plus 24, which is 25 over 4. Well, we know what the square root of 25 is. That's 5. So that's 1 plus or minus 5 over 4, which is 1 plus 5 over 4 or 1 minus 5 over 4. Well, 1 plus 5 over 4 is 6 over 4, which is 3 over 2. 1 minus 5 is -4 over 4, which is -1. So if you can see that it factors, it's way faster. But if you're going to do the quadratic formula, it works. I would not complete the square here, because if I have 2 p squared boxes, each box gets a half and each side gets a quarter. And I don't want to mess with it. Okay, so let's try 30. Looking at 30, what would I try to do? I definitely would try to factor. Let's see if it factors. Make your list for -12. 1 and -12. 2 and -6. That gives me -4. I'm looking for +4. So just change the signs, -2 and +6. So when I factor it, it's b minus 2 and b plus 6 equals 0. Well, that's easy to solve. B minus 2 and b plus 6 equals 0 means either this guy equals 0 or this guy equals 0, and b equals 2 or b equals -6. What if you didn't see it? You could complete the square on this one or quadratic formula. Since I just did quadratic formula on the last one, I'll go ahead and show you what completing the square looks like on this one. What square is this closest to? It would be a b plus 2 square. Because I have a b squared, I have 4b, so each side would get 2. That would put a 4 in the corner, but I don't have 4, I have -12. So I had to get from a 4 to a -12, I'd have to take the 4 away, and I'd have to take 12 more away, which would take away 16. Once it looks like this, you can solve. You get b by itself. Add 16 to both sides. B plus 2 squared equals 16. Square root both sides. Don't forget your plus or minus. B plus 2 is plus or minus 4, and then subtract 2. So I get B equals -2 plus or minus 4, which are two problems. -2 plus 4, -2 minus 4. Once again, 2 and -6, which we got from factoring way faster. So if you can factor, please factor. Okay, 32. 32, I can get m by itself, right? You can just add 16 to both sides. Get m squared equals 16. Square root both sides. Don't forget your plus or minus. M is plus or minus 4. Other things you could have done, you could have factored. If you saw that was difference of two squares, you could have said, well, that's m minus 4 and m plus 4 equals 0. One of those would have to be 0, so it would be 4 and -4. Okay, what do we got here? We're going to pause real quick, and I'll post another video in a second with the rest of these.